Your final exam is next week during your class time. It's going to be available beginning of your class time and is going to end at the end of your class time. So we have questions that are multiple choice. We have questions that are free response. Based on the modality of the test, because it's an online test, I'm not asking to draw the structure or draw the setup. I usually do. For a face-to-face class, I ask for drawing of, let's say, setup for simple distillation or fractional distillation, or setup for extraction, or whatever the setups. What I can do, I can give you a picture of a setup and number like different places, and then ask you what is the name of that equipment or the function. Basically label the different parts of that diagram or the setup. Just be mindful of that. So you need to know how was the setup. That's why I keep asking, take a screenshot of the setup so you know how it's connected, and when I assemble, I explain which parts are going which, and then I kind of name those equipments. And most of the images are in the lab manual, so you can just make sure that you know how to name and what are the different parts. Calculation, I used to have a calculation for percent yield because you have practiced that at least for 2 experiments. Experiment 9 and experiment 3, you do the calculation for percent yield. Expect that as a question. I don't have the final exam written for your classes specifically, but generally is going to I'm just explaining how the exam would look like. For experiment 1, for example, the other questions, you get the type of questions that is like very similar to pre-lab, based on understanding of the procedure and understanding the lab technique. For experiment 1, you measured physical properties and you measured solubility. Like, what's general rule for solubility? If the compound dissolves in water, what does it mean? That is like polar, right? If we're measuring melting point, what does broad range of melting means, or what is the conclusion or interpretation of that data? What versus sharp melting? If you have a compound that you know the name of the compound, how would you know your compound is pure or is not pure? Based on the depression of the melting point. If you already know is it, let's say 200, and you find the melting point to be 160, that the melting point is low, that means it's not pure. And then you have the other just the application of and setting up the techniques. When you are filling up the capillary tube, why does it have to be filled up properly, that there is no gap or air bubbles? I'm looking for keywords in the answer. So like the distribution of the heat is not even, or air is not good conductor of the heat. So I'm looking for keyword. Please do not just say that and this is recorded also, do not say that the melting point would be recorded wrong. Yes, I know, and you know that is going to be recorded wrong, but what is causing the melting point to be wrong? When you are heating the sample, when you heat up the sample like too fast, if the rate of the heating too fast, how would that affect the rate of the reaction? Or I'm sorry, how would that affect the melting point? What I'm looking there is the key word that thermometer is lagging the temperature of the sample. The sample gets hot, but the thermometer doesn't get a chance to show that number. So it has to be question or the answer that actually shows the cause and the effect, not just general answer that. Okay. And questions that nature. When you look at the pre-lab. All the pre-labs are recorded. Pre-lab discussions are recorded. And if you go to Blackboard Collaborate from the communication, and then you go top left corner, the 3 lines, you look for recording. If it doesn't show all the dates, you go to the right line, right side, and then you have the recording in range. You click on that, you go from beginning of semester to end of semester, you see all the recordings. So you just have to adjust the date to see all the recordings. And we talked about all the techniques beginning of the lab. During the pre-lab discussion, I asked questions, you answered, and you need to just review it. Experiment 2, distillation. Distillation is a technique that you purify liquids, and we have different types of distillation. The compounds are separated based on their boiling point. What's boiling point is when vapor pressure equals atmospheric pressure. So if I give you a graph that shows vapor pressure increasing as the temperature is increasing, you should be able to tell me, you know, what's the boiling point at any given temperature, what's the pressure, or at any given pressure, what would be the boiling point. So basically being able to read the vapor pressure line, that let's say if it's in 1 atmosphere, then temperature corresponding to 1 atmosphere, it would be boiling point. If the atmospheric pressure is lowered, boiling point would be also lowered. And then you have different type of distillation, fractional and steam distillation. When are you using those? How they are different in terms of the apparatus and the application. Like steam distillation is used for compounds that they have high boiling point, and there's a chance for decomposition. To avoid decomposition, you would use steam or water to distill it, and because it's immiscible, it must be immiscible. Recrystallization. If you don't get crystals, what would you do after you cooled down? So similar questions to the pre-lab. Again, what's proper solvent for recrystallization, and what should be? The pre-lab discussion includes all those questions and the answers, and also you have those questions in the pre-lab quiz. Extraction. So going back to like recrystallization, you get low percent yield, less than 100%. That means you've lost some product. If you get high percent yield, that means that your sample is not pure, or your sample is not dry. And how would you know your sample is pure or not? If you take the melting point, if it's sharp melting, then there's a great chance that your sample is pure. When you do extraction like acid-base extraction, is you cannot separate 2 compounds that they have exact same functional group. Like if you have 2 acids, you cannot separate them from each other by extraction. You have to use a different technique. So the extraction is based on reactivity and of one compound versus the other one toward one single reagent. So you can change your compound to soluble compound. You are using separated funnel. You have organic layer and you have aqueous layer. Organic layer, you always use anhydrous agent. So you basically pay attention to chemicals that you are using for each experiment. There aren't many, but if you are doing extraction, like you would use calcium chloride or sodium sulfate or magnesium sulfate to dry the organic layer to remove the excess of water or trace amount of the water. So you are going to know what's the purpose of the experiment, what is the application for that experiment, and what are the limitations for that experiment. After that, you did chromatography. For chromatography is a technique for separation and for identification. The advantage and disadvantage of the chromatography is that you can use basically very small sample. That's the advantage. The disadvantage is that you have to have known and unknown in the same plate, because you cannot use the unknown on one plate and then known in another plate or another day. You have to have a good comparison, point of comparison for like a TLC. for identification. You could say if your compound is more polar or less polar, but in order to identify it, you have to compare to the known sample at the same place, same condition. Then after chromatography, you do the steam distillation. With steam distillation, we talked about that the sample must be immiscible in water. So other techniques, so these are 6 experiments. 6 experiments is just based on techniques. Organic one emphasizes more on techniques. And when I'm writing questions, that's in my mind. I'm testing for your techniques and being able to interpret the data that is coming from these techniques, basically. If the melting point is broad, what does it mean? If it's sharp, what does it mean? If the solution that you get from steam distillation or organic layer is cloudy, what does it mean? Do you have to add anhydrous agent? What you need to do to make sure that is going to be dry, free of water, basically. And then you have your experiment 7, 8, 9. I'm not going to include anything from experiment 10 for the exam. You have your experiment 7, 8, and 9, which basically you did the calculation for % yield. You did dehydration of the alcohol. You get 2 product, major product and minor product, and one is more stable than the other. The experiment 9, different alkyl halide, which one would go to SN1, which one would go to SN2, to the SN2 reactions. Those are good questions for multiple choice, but the major concern for this exam is techniques. So I just want to make sure that you know. Exam is going to be partially multiple choice and partially free response. You get anywhere between 25 to 30 questions because you have some multiple choice questions. I can't put like 10 or 12 only. So I have to increase the number of questions. Okay. I'm done with the review. Basically, you are going to study and watch the pre-lab discussions again, read the experiment, remember what is used for what's the purpose of using anything in the experiment or in the procedure. Questions for me? Yes, do review 7, 8, 9, but it's not going to be as heavy as experiment 1 to 6. Have general understanding of 7, 8, 9. Yes. Okay, perfect. Any questions? I'm going to stop if you don't have questions about the exam review, I have a question for you. So do you know what to study for the exam? Yes or no? Based on my explanation, do you know what to study? Yes, pre-lab discussions. Perfect. Okay. Pre-lab discussions or pre-lab quizzes and the procedures. So very good. Let's be because data analysis is part of the lab competencies. I want to make sure that when you have a graph, you know how to look at it also. That could be for the distillation graph, simple versus fractional distillation graph, which one is more efficient, or it could be based on like a vapor pressure, or I think those are the only 2 graphs because I'm not including experiment 10. Okay. Going to stop recording and I'm going to label this as